Hello everyone. Now in this video I'll be working exercise 12E number 1, 2 and 3. I will be separating this video into chapters so you can actually switch between whichever question you would like to actually focus on. So we're saying that we have A, B, C and D are the points of the position vectors where we have I plus j minus k, which is going to be A, I minus j plus 2k, which is B, j plus k, which is C, and 2i plus j, which is going to be D. And for question 1, we're going to look at solving for the modulus of AB and the modulus of BD. So, in starting here now, what we're actually going to do is simply just state what A and B are. Not in the terms of their components here, but in terms of their values. So A is going to be equal to, if you look at what we actually have here, I is just I, so that's 1. So it's just j, that's also 1. And it's a minus k, so this is minus 1. And for B, what we have is I, so it's 1, minus j minus 1, plus 2k, so this is going to be 2. Now, moving forward, we're going to look at the linear components, so this is b minus a, and what this is going to be is 1 minus 1, 2, subtracting 1, 1 minus 1. So with this being done, we have 1 take 1, which is 0, minus 1 minus 1, which is going to be minus 2, and 2 minus a minus 1, which is going to give me 3. Good. So after we actually solve for that in the vector components, we're now going to look at solving for the modulus of AB. So the modulus, or as you would want to say, magnitude of AB is equal to the root of, well, I'm not going to write 0, so we have minus 2 squared plus 3 squared, which is 4 plus 9, which is going to be the root of 13. So the modulus AB is equal to the root of 13. Good. Moving on to the next one, we're going to look at solving for the modulus of BD. So B is going to be equal to, here we have it, we're looking again for the number values, so we have 1, minus 1, and 2. And for D, what we have is, so D is here, we have 2, I, so that's 2, J, which is 1, and we don't have any k, so I'm going to put 0 there. So just a reminder, I is x-axis, J, y-axis, k, z-axis. Okay, so what we are now going to do is similar to what we've just done. We're looking for the vector component, so writing D first, we have 2, 1, 0, minus 1, minus 1, 2. So another way you could think of it is saying we have the terminal point, the end point, minus the initial point. And this is going to give me 2 minus 1, which is 1, 1 minus a minus 1, 1 plus 1 is 2, and 0 minus 2 is minus 2. As a result, the modulus of BD is going to be equal to the root of 1 squared plus 2 squared plus a minus 2 squared, which is going to be 1 plus 4 plus 4, which is going to give me the root of 9, which is going to be 3. As a result, the modulus of BD is 3. Good. So we're now going to move on to number 2. We're looking at finding the cosines of CD and vector AC. So before I actually go into anything else, since we're given it in I, J, and K, I'm going to have cosine of the angle I is equal to the vector that we have divided by what we're actually going to find the magnitude of, which is CD. Okay, and it's going to be for the same as for J and for K as well. So it's the angle, so let's just say cos theta is equal to the vector of whatever we're going to solve for divided by the modulus that we actually will solve for as well. So with that being said, let's begin. So for C, again we're looking for the values. So C is going to be equal to, where here is C, we have J plus K, so that's going to be 1, 1 HI. So we don't have anything for I, so it's 0, 1, 1. And D, what do we have? We have 2I, so we have 2I, so that's 2x. We have a J, so that's going to be 1. We don't have a K, so that's going to be 0. So looking for the component now, we're going to subtract the terminal, the initial from the terminal. So we have 2, 1, 0, subtracting 0, 1, 1. So 2 takes 0 is 2, 1 minus 1 is 0, minus 1. So remember, this is I, this is J, and this is K. So moving on now, we're looking for the modulus of CD. So we're going to have 2 squared plus a minus 1 squared, which is going to give me the root of 5. Good. So like I outlined earlier on, whatever vector we have, we're going to be dividing it by 5. And notice it's commas. So what this actually means, trying to scroll down, good, is we have 3 possible solutions since our vector that is in 3 dimensions. So what I'm saying again is simply this. We're going to have the cosine of the angle I is going to be equal to what we have I is. I is 2. So we have 2 over root 5. Now, of course, we need to rationalize this. So we have times root 5 over root 5, giving us 2 root 5 over 5. Okay, so no J is 0, so the cos angle J is going to be 0 over root 5, which is 0. And cosine of the angle K is going to be minus 1 divided by root 5, which is going to be root 5 over root 5. So you have minus root 5 over 5. And these here are your answers for the, what is it, the cosines of CD. So we're looking at the cosines of AC now. So A, the values we have 1 I, we have 1 J, and we have a minus 1 for K. And for C, so this is A, this is B, C we have just J and K. So we have no I, we have 1 J, we have 1 K. So we go into terminal minus initial, so c minus a is going to be equal to 0, 1, 1 minus 1, 1 minus 1. So this is going to give me minus 1, 0, and 2. So again, this is I, this is J, and this is K. So again, we write out the cosines next. So another way you could see it is alpha, beta, and gamma as well. But I'm going to stick with what I've started with. We have percent cosine the angle I is going to be equal to minus 1 over root 5 just times root 5, which is going to be equal to minus root 5 over 5. Next is cos of j, and we are going to have 0 over root 5, which is going to be 0. And now cosine k is going to be 2 over root 5, which is going to be root 5 over root 5 multiplying, giving me 2 root 5 over 5. So those are my 3 possible answers there. And now finally for number 3, we're finding the position vectors of the point which divides BC internally in the ratio 3:2 and divides AC externally in the ratio of 3:2. Now something to actually note here, when you're solving for it internally, you're going to add. And when you're externally, you subtract. So that's a very simple thing to understand. However, there's some flipping that you'll need to focus on. So let's start with BC first. So BC is equal to, now I'm going to write something and then I'm going to try my best to explain what I'm going to do afterwards. So B is, so remember this is A, this is B, so we have I minus J plus 2K. I'm going to add this to C, which is J plus K. Now, since we're dealing with ratios, we're going, of course, and instead internally we're going to add. So what I'm adding is 3 plus 2. Now, in terms of explaining this, it's very complex. You would need to see a drawing to actually understand this, what I'm about to do. But the easier way to actually look at it is by using what's the ratio that's at the back, which is 2, in front, and you use the ratio in front as what's at the back. It's a way of saying what is closer. I believe I did see a video on YouTube explaining it, but again, even the lecturer doing the video said that, yeah, it's a little bit complicated to remember. So all I'll say is when you see add, you need to add your ratio components. What's at the back goes in front, what's in front goes at the back. That's just the simple way to actually do it. But for an explanation, I'm going to link that video to this one. Alright, so with that being said, moving into solve, we're going to have 2i minus 2j plus 4k plus 3j plus 3k, all being divided by 5. Now I'm not going to go into grouping because, again, we could see this. How many i's we have? We just have one, so we have 2i. So j's, we have 1 here. We have, so minus 2 plus 3. It's going to give me 1, so this is just plus j. And then we have 4k plus 3k. This is plus 7k. And this is all being divided by 5. Good, and here now we're at the last question. Now, as I outlined, when you're external, you're going to have to subtract. So you're looking at 3 minus 2. and 3 take 2 is going to give me the answer of 1. There's something else I need to go through in relation to how you're going to do this switching for external external ratios. So let's go again. So AC, where A is equal to I plus J minus K, and C is equal to J plus K. What we're going to do is what I did before. I'm going to have AC, and this is equal to, I have I plus J minus K, which I'm going to put in bracket. I have my plus side, I'm going to leave a space, and I have J plus K. They're going to be divided by 3 take 2, which is going to go here. Now, notice we have a change in the sign. So this minus 2 is going to go in front, and the 3 is going to go behind. So it's the same idea of what's at the back is closer to what's in front and vice versa. Again, when you look at the video, maybe you'll be able to grasp it a little bit better than I did. Okay, so going into now finalizing this, we're going to have minus 2I minus 2J plus 2K plus 3J plus 3K and 3 take 2, which is 1. So we know anything divided by 1 is itself, so in our next line we just need to have an answer. So we have 2I, it's a negative 2I. Right, so we have minus 2J and plus 2J, so again if you have positive J, and 2K plus 3K is 5K. Yeah, and with that being said, this is going to be the end of the video. I hope it's found you well, and do enjoy the remainder of your day.